Right, so welcome to Vulnerability Management Sucks, or should I say Windows Sucks. My HDMI just decided to die, so I apologise about that. But proceeding on, because I've already wasted enough of everyone's time. Mandatory who am I slide. Total B-sides Alex. I've nearly been going to conferences for about 4 years or so now. Roughly 2.5 years on the Blue Team. I unironically use Arch, so if you'd like to leave, please do. And there's my Twitter handle if you want to listen to any of my nonsense. So as a bit of a scenario summary, I'm going to try to deliver quite a breadth of content in a relatively small space. So when we talk about vulnerability management, massive topic, I'm mainly going to be complaining about the reporting cycle. So mainly in the context of infrastructure patching, anything you can really stick a CVE to in terms of vulnerabilities. So general scenario, when you're first starting out doing vulnerability management, you may start with some informal patching policy. You may be doing various things. Eventually you start scaling up. Either you manage to convince management or you get forced via regulatory audit whatsoever that you need to have a vulnerability management solution. You onboard one of those. You may onboard a few more. It depends where your devices are. Some support Windows better than Linux. You may have a mix of various scenarios going on, which means you end up having multiple devices, multiple management systems, and you end up in a state where you're sending out and scheduling reports to system owners. So the evolving situation we have multiple VM solutions. We've got various other data sources maybe coming in. It's just a split kind of cloud on-prem environment as an example scenario. We may have some information coming in from our cloud assessments, some pen tests as well, providing you can stick a CV to those. And we're just dealing with a lot of different environments, a lot of different stakeholders, system owners. And the question that really evolves at this point is, do PDFs still go blur? And the answer to that is it's a complete dumpster fire. We're now dealing with lots of data. Prioritization is becoming a nightmare. Sending PDF reports or reporting to system owners that contains problems of vulnerabilities is not intuitive. We're facing pressures on doing reporting. We need to establish mean time to patch, SLAs. We need to be able to do audit trails on our system owners' kind of activities for what everything that's going on. And it's not easy to do with the current sort of solution we've got in place. Too many different systems, it's just a headache. Managing different vulnerability management solutions is just annoying. We don't have to bounce between back and forth of things. And also sometimes different systems will have different rating scores. Proprietary will go from high to low, critical to urgent, 0 to 1,000. And generally, it's annoying. And we don't want to be putting any more manual effort in running around chasing things. We've already got too much to deal with as a SOC team in general, or an InfoSec team. So what I would establish as the pillars of sane reporting is anything other than a PDF, for the love of God. Generally, PDFs are nice for executive reports, but elsewise, we need a system that makes findings auditable, actionable, and prioritized. Generally, when you're sending around reports like this, especially if it's in like such an email chain, it gets a bit hard to track. Actionable in the sense that we don't want to have a bunch of items on a PDF. We want to have more clear view of what's our main priorities, and so forth. So by doing this, we need to account for different system owners and stakeholders at the same time. What's their capability? What's their capacity? What support systems we need in place for supporting certain remediation activities? We also need to establish appropriate SLAs and metrics based on that. And finally, automation. So we should be the fourth eye in this whole process as we build this automation out. We don't want to be the judge, jury, and executioner. We don't want to be patching people's stuff for them. We want to be serving the reporting, and maybe we will if there's some disastrous vulnerability running about. We'll go scream at everyone, but we generally don't want to allocate effort and full-time employees towards this unless we have the capacity for it. So, in a general attempt to solve the madness, we effectively create some sort of system that looks like this to process all that information. So we take all of our various vulnerability management solutions, any of the data sources we may have, network scanners, etc., and every X period, whenever we want to run our reporting, or maybe continuously, we'll produce just an artifact of the state of our sort of vulnerability management estate, the lay of the land. and then we put it through effectively a data pipeline to normalize, enrich the data, and produce something we can use. Generally, when it comes to this, in the normalization phase, some magic may be going on, but generally we're going to use the NIST National Vulnerability Database and the CVE database as a source of truth. Find out why on later slides, but the vulnerability management solutions we have may always not be that reliable. When it comes to enrichment, generally we just want to make sure we tag on correct system owners. The correct sort of risk scoring. CVE is not always the best to do prioritization with. And once we've got all that data in a nice parsed sort of artifact, whether that sits in some sort of database of some kind, we can run some sort of automation on that to pretty much just generate backlog items against priorities, so forth. And then maybe we want to put that in some nice, neat dashboards for our system owners, stakeholders, etc., just to kind of have it immediately available to them. What is the highest priority of what I want to do right now? What is the general lay of the land? So in implementing this system, there's some common chaos. So firstly, artifacts. We know we need to get a artifact of effectively what our estate looks like. How can we automate this? We're going to use APIs. And that would be so easy, brilliant, if it actually was that simple. So, generally, some systems may have a nice JSON API that you can just interrogate, pull information out of. Brilliant. Other systems, right now, why I wasn't around in sort of late 2000s, early 2010s, will have maybe XML APIs, which, depending on whether they provide you a schema or not, may or may not be less tolerable. Generally, that's my reaction whenever I see an XML API. Not very happy, but at least you can work with them. And then when we don't have that capability, we may manually opt to extract a CSV if we can. We just need to get the data in some format. If we can't do any of the above, and we have a solution that effectively limits us to sort of HTML exports or PDFs, we're going to want to make some considerations on vendor selections, really. If we can't get that information to us so we can parse it, what's the point of having these solutions if we're going to struggle to scale? So that's mainly just in case of we should switch to some other solution. Normalization, so this is just the vulnerability management Blender extravaganza. So generally, the data you pull out of these APIs and what you get from these systems, it will vary. So you'll have weird behaviors. You'll just have null data in some places. Unpublished vulnerability is an example of this. So some systems may contain a vulnerability, and you'll say, okay, well, this vulnerability is here, we should patch it, or it gets reported. But it's actually unpublished. It's within the CVE database, and through whatever means, that sort of vendor somehow is able to detect it. Not exactly sure, all the technicals around that. But when you do that, you end up with just null fields for CVSS scores, and that is extremely annoying. So pretty much when we do normalization, we just ignore half of what we're given, and we just say, what's the CVE ID? Go to the NIST databases, CVE databases, and pull a source of truth we can actually rely on. And sometimes we encounter conflicts in reporting, so not necessarily whether a certain system or a managed solution has detected more CVE IDs than the other. It's more that where, a good example is maybe sort of Windows security updates. We'll have one system reporting a certain amount of KPIs and vulnerabilities, and another reporting less, and then you find out one of them is reporting it for every architecture. And we may trust certain systems more to evaluate certain pieces of software. So that's just a consideration we may have. Now, the next bane of my existence is just standards. So we're all familiar with CVE IDs and such, but what else? So we have the Common Platform Enumeration, which in a nutshell is just software naming standards. So when you pull data out of these systems, and you kind of compare them, sometimes these systems are great and they'll do that, sometimes not so much. So generally, in terms of what's more human readable, yes, Firefox vulnerabilities is. In terms of what's parsable and processable, that's terrible. We much prefer a nice CPE that we can use to figure out what piece of software is problematic. Again, NIST, CVE, absolute saviors. All those databases in the given vulnerability, they'll have those CPE IDs attached, so you can just go ahead and grab them and use that instead. Enrichment. By this point, if you're sending out reports to people, I hope your assets are tagged, because you need to know what assets are what in order to send out reports in the first place. But generally, this is just if you want to add any more information, additional asset ownership information, resource IDs, if we have various assets across the cloud, so forth. And most importantly here, we probably want to come up with some sort of weighted risk matrix calculation sort of system, so we can effectively assess by our tiering of our applications or servers what is the highest criticality for us that we need to immediately patch, what's the most exposed. Generally, your innovation teams, your DevOps teams may have tiering more laid out than some of your other teams or some of your other system owners. You may have to do some work on this. And providing this entire kind of methodology, this system goes well, the result is we have some nice neat dashboards. Everything's prioritized by known exploitable vulnerabilities first. It links to all the information that someone remediating the vulnerability would need to know how to do it. And we've already made their backlog item for them. All they need to do is allocate sprint time. So in this case, we still need to think about deferral, acceptance, all the things that come with the sort of vulnerability management, which effectively we'd have to implement ourselves, as mentioned with that previous system. It's just more engineering work. So at this point, you're probably thinking, well, vulnerability management sucks. Can we throw money at people to do this? Yes, but there's some considerations first. So we have unified vulnerability management platforms. You can go search them on Google, plenty will come up. They can't magic APIs out of nowhere. We still have issues if you're with artifact generation. If your systems don't have APIs, you can't get data out of them. They can't fix that for you. You lose some flexibility on overrides. Sort of that mention of the example earlier. You can't granularly say we trust this system more for a certain piece of software or whatnot. And they have their own proprietary rating systems. So generally, if you want a truly accurate rating system for prioritization, the only real way to do it is yourself. But this is a great start. So if you have limited engineering resources, but you have plenty of budget, then feel free, chuck money at them. They'll make your life easier. And if you are going to be doing it yourself, general considerations: maintenance. If you do not maintain the system, it will fall apart. Also, automation also has to scale, and now we're kind of more thinking DevOps. 1,000 lines of Python code, not a good idea for this system. You need a scalable system that effectively is now thinking about kind of microservices, all the kind of considerations you have when you're just developing software effectively. So that is the summary of why vulnerability management sucks and what we can do to make it suck a bit less. Now for questions management, if anyone has anything to ask after I wasted the 10 minutes at the start of the talk fumbling with a HDMI.